Okay, like I was saying, plan for today is basically just some more review. Okay, just trying to make sure that everybody's on the same page, everybody's understanding what we're doing before we move into next week. Where next week we're going to wrap up the chapter. We're going to talk about kind of two other methods. There are kind of more methods of factoring. There are different ways of doing stuff, and we'll talk about that next week, the 2 different days, and then we'll finish out the chapter from there. And we'll go from there. So. First thing I had you take out, though, was this worksheet, the worksheet that I gave you for homework the other day. And so if you take a look at the graphing polynomials worksheet, I asked you the other day to go through and kind of what we were doing in class. Go through and find the y-intercept, find the x-intercepts, what's the degree, the value of a, those types of things, so that we can come up with a decent sketch of the graph. So I guess I want to kind of open it up to questions. Anything that, as you were working your way through this, by the way, is due for full credit. This is due by midnight tonight. Okay, so this is, you still have time to go over questions, finish it up, and still get it turned in for full credit. But yes, yeah. No, you don't have to worry about that. No, you can go through and just, you don't have to do the last step. Once you find the x-intercepts, the y-intercept, the end behavior, that kind of stuff, you're fine. Okay. Anybody have any questions that you want to go over? Work your way through? Anything? Nothing? Okay, then let's go back to the other packet then. Let's go back to this multiplicity. There's a couple other ones that I wanted to go through today kind of quickly, just as examples, just to refresh your memory on this a little bit, and then we'll go into, and then like I said, you'll have kind of some work time where if you have individual questions, you'll be able to ask those questions. So the page that I wanted to go to was, let's see, next one. Let's take a look. Problem number 4 here is what I want you to take a look at in kind of the lesson packet, if you will. And I gave you kind of the factored form, but I wanted to go back to how we got there, okay, and the process of getting there, because that's what we talked about last week. Parker, you said you're coming from Strumkowski, you said, right? Okay, and so we'll take a look, and like I said, I don't know exactly where he was at versus me, so I want to make sure you are understanding. So if you take a look, if we're going to go through and let's just work our way through a couple of these problems. This will be the kind of last one where the equation is given. Then I'm going to skip to a couple where you're given the graph, and we'll work backwards and come up with the equation, okay? So first off, what's the general shape of this graph look like? The general shape look like? Remember, it's always based on 2 things. Degree and the a value. Tells you the general shape. What do you think? Connor, what do you think?
It could be like going up and down, and it's like the roller coaster one.
Okay, yep. We've got a positive x cubed, okay? The x cubed is kind of the S-shaped roller coaster looking graph. And because it's positive, starts down low and will end up high, okay? So it's going to end up looking something like that. That's going to be the general shape of our graph right there, okay? So with that being said, let's put the end behavior in here. And let's go as x goes to negative infinity. That means, where does y start? X is going to negative infinity. That's the start of the graph. Positive or negative infinity? What do you think? Kyle, what do you think? Positive or negative infinity? Where are we starting in this graph?
Positive. We're starting at a negative.
Starting down at negative, right. Starting at a negative, and we're going to a positive. So the first y value when x goes to negative infinity is negative infinity. And then as x goes to positive infinity, the right side of the graph, that means where are we ending? That means we're ending up high at positive infinity. Okay, so there's the end behavior that matches what the graph is going to look like. Now, if we go through, I'm gonna kind of skip to the y-intercept first, just because it's a lot easier to find than the x-intercepts. So if we go through and I put that in here, y-intercept is at 0 what? Yeah, 0, 100. Plug in 0. It's your constant. It is 100 in this case. And so then finally, if we take a look at the x-intercepts, we got to look at how are we going to go about graphing this, okay? And so if you look, first question always, is there a greatest common factor that I could take out of everything? If there is, we always should do it because that way we can simplify things. If not, then we'll move to the next step of the process. What do you think? Parker, any greatest common factor? Anything we could take out of everything? No, you're right. Yep. There's nothing to remember. It's got to come out of everything. Notice there's a couple of terms have something in common. Okay, there's 3 out of the 4 at least have an X, but if it can't come out of everything, then we don't have anything. So that leads us to the next question then. Do we have 2, 3, or 4 terms? Because that'll kind of tell us how to factor. If it's 2, if you remember, the idea behind it is then it's one of those special cases. It might be a difference of squares, difference of cubes, sum of cubes. If it's 3 terms, then we just factor it like a quadratic factoring, okay? And if it's 4 terms, which is what this is, then we do the whole factor by grouping. We do that box method, okay? And that's kind of why I picked this one. I wanted to go back over that box method to make sure everybody saw that and understands that. So if we do that, if you remember back to in Algebra 1, when you learn the whole box and diamond method, we're going to just use the box portion. And remember what I talked about before? First and last term need to go on one diagonal. So I'm going to put the x cubed here. I'm going to put the 100 there. And the 2 middle terms go on the other diagonal. So we have a negative 4x squared, and we have a negative 25x. Okay, so the first part is just organizing it. First and last on one diagonal, middle 2 on the other diagonal. Okay? So now if we take a look, now it's just a whole bunch of greatest common factors. Let's go rows and columns. First column, what's the greatest common factor that I can take out of x cubed and negative 25x? Comes out of that. What do you think, Cal? What do you got? What's coming out of the first column?
X squared, or just X?
Just x, there you go, yep. So just x comes out of there. How about the second column? What can I pull out? Keeping in mind, I want the higher degree term positive. What do you think, Gabby? Yeah, 4 goes into both, and I'm going to pull the negative out because I want the x squared to be positive. So I'm going to pull a negative 4 out. There's your first factor right there. Okay? First factor is x minus 4. Now we go the 2 different rows in this case. Top row, Sophia, what are we pulling out on the top row? Yep, we got an x squared I can pull out. And how about the bottom row? Again, keeping in mind I want the higher degree term to be positive. What can I factor out of that? Naomi, what do you think? What can I factor out of the bottom row? Very good. Negative 25. Okay? There's your other factor right there. We got x squared minus 25. So now the question is, there's your factors. Question is, could I factor either of them any further? And the answer is yes. I've got a difference of squares right here that I can go a little further. So in this case, we're going to go x minus 4. And then this, being a difference of squares, is going to be x plus 5 and x minus 5. Okay. X and 5 are the 2 things being squared. The plus and the minus, so that we don't have any middle term that's got an x in it. It cancels out and goes away. So now if we take a look, now I've got the 3 factors, which means down here then, this tells me that x equals 5 is the first 0. This factor tells me that I've got x equals negative 5 as my second 0. And over here then we've got x equals 4 as the third one. Okay? And what's the multiplicity of each of those? A multiplicity of 1, 2, or 3? It's 1. There's only 1 of each of those factors. None of them are squared. There's not 2 of the same factor, which means what that tells me about the graph is that each one of those is a multiplicity of 1. It's going through the x-axis at each of those spots. Okay? So let's put this all together then. We've got negative 5. We've got a positive 4 and a positive 5. And we've got a y-intercept, we said, way up here at like 100, which, like I said, we'll just approximate that way up there. And so if you take a look, and because of the end behavior that we talked about, we know it's got to kind of look like that as well. So it's going to come up go way up here, come back down, and then right away turn around and go right back up. Oh, sorry, I hate that noise. My apologies. And there's kind of what the graph looks like. Okay, at least a rough sketch that it's got that cubic shape to it. It goes through the different x-intercepts that we found, goes through the y-intercept that we have. It's got the correct end behavior, that it's starting low, ending high. Okay, so we're kind of, like I said, kind of putting everything together on this one. Main reason I picked this one though, is I wanted you to see the box method again. Okay, I just wanted you to go back to seeing the box method. All right, last thing I want to do then in the lesson packet is go to the back side, the last two problems then. Did we do either of these the other day? I know in one or two of the classes I think I did number 6. All right, let's just take a look. This is basically just working backwards. We're going to, given the graph and the shape of it and the x-intercepts and all that kind of stuff, we're going to work backwards to the equation now instead. Okay? Same concept, just in reverse order. So first question, if we go through, I'm going to put down y equals. And I'm just going to work my way through the x-intercepts. Okay? If it's going to be in factored form, remember, you can easily take a 0, an x-intercept, and turn it into a factor. So first one right here looks like it's at -2.5. That's the best that we can come up with. Which means if it's -2.5, what's the factor? Yeah. X plus 2.5. Remember, it's always to go from a 0 or an x-intercept to a factor. It's always x minus whatever the 0 is. So since this is a -2.5, that's why it's x plus. Okay, so we're going to go x plus 2.5. What power is that raised to? 1, 2, or 3? Why 3, Abby? Yep, this is the one. Remember, if it goes through the graph, it's 1. If it touches and bounces off the graph, it's 2. It's double root. And if it kind of just flattens out and sits right on the graph, then it's a triple root. So in this case, we raise it to the third power. Okay, now we come over here. What happens when we have, first of all, it goes through, so I know it's just the first power. But what happens at that point? What's the factor then? Don't overthink this one. What's the factor if it's at 0? What do you think? Callaway.
It's just X.
Yeah, x minus 0, which therefore is just x. So our next factor is that. It is just x. As a matter of fact, I'll even just put it in parentheses just so it's by itself there. And then we move to the next one, which looks like we're at 1. Again, it goes through the x-axis, so it's only got a multiplicity of 1. And therefore, our last factor is x minus 1. And with the information given in this graph, that's about as good as we can do. By the way, quick question. For this graph, is the a value positive or negative? That's the one other thing we could adjust. Based on the graph, is a positive or negative? Positive. Why do you say that, Abby? Yep, because it starts down low and it ends up high. And the fact that they start and end in 2 different spots tells you that the degree of this is also an odd degree. So if you take a look, 3rd degree, 4th degree, 5th degree. Okay, so according to our factors, we're saying that this is a 5th degree function. Matches up that it has opposite end behavior, positive a value, which by the way is pretty much the only thing right now that I don't necessarily have. Okay, and so in this case we're in good shape, and we can just leave it like that. There's your graph. Okay. So we know that we're at a positive 1 on this case for an a value. If, by the way, just as a heads up, and we'll get into this a little bit later in the chapter, but if I had some other y-intercept, I would have to take that y-intercept and kind of plug it in to actually solve for the a value. Okay, we'll get to that. We'll do that, but that's the one piece where I don't really have a number. I just know it's positive in this case. All right, let's take a look. Last one. How about number 7? So we're going to write a possible equation for this. Okay, so y equals. Again, let's just work our way through this. Here we've got -2. Therefore, what's the factor? -2 is the x-intercept. What's the factor then, Kyle?
2.
Okay, yeah, it'd be x plus 2. So we've got x plus 2. It goes through the x-axis, therefore it's only a multiplicity of 1, so it's just one of those factors. We come back, -1. That is 0 number 2, or factor number, or x-intercept number 2. Therefore, if it's -1, that means we've got an x plus 1 for a factor. We keep going. Oops, must have moved the. Put that back. We keep going. Now we come back to the origin and it bounces off. Therefore, what am I going to write down? It's at the origin, so you got 0 and it's bouncing off at that point. X squared. So it would be x normally, but because it's bouncing off, now you got a multiplicity of 2. So now you also have a factor of x squared. I'm going to put that in parentheses as well. And then we keep going. We've got one more over here at 2. And therefore, x minus 2 is the factor that goes with that one. Last question. Positive or negative a value? Positive or negative? What do you think, Connor?
Negative,
Yeah. And why is it negative?
because it's going from like top to down.
Yeah. It's going from positive infinity, it's starting, and it's ending at negative infinity. So it's got that general decrease to the graph. So I know that my a value is going to be negative, so I'm going to throw a negative in the front as well. Okay? And again, if we just kind of check, because it's in 2 different spots, that means it's an odd degree. There's 1, there's 2, there's 4, once again, there's 5. So we ended up with a 5th degree function based off of this. Okay. So the goal at this point right now, hopefully, is if you're given the equation, you should hopefully be able to factor it, find the y-intercept, find all the important stuff, and graph it. If you're given the graph, you should be able to come up with the important features off the graph and write it out in factor, at least in factored form. By the way, what if I went one step further and said, I'm not going to do it, but what if I asked you to write this in standard form instead? What would you now have to do? Like I said, I'm not going to do it, but what would I have to do? What do you think? Sophia, what do you think? Yeah, we'd have to multiply everything out. We'd have to go through and take x plus 2 times x plus 1, multiply that all out, then distribute an x squared through it, then go through and distribute an x minus 2 and multiply that whole thing out if we wanted it in standard form. Okay? Again, that's something that we'll get to, probably not for 5th degree, but that's something we'll get to as we work our way into the future. Okay? Does anybody have any questions? Otherwise, I'm going to give you the next worksheet. There's one thing I want to mention before I turn you loose and let you start working on it. But let me give you this. Real quickly, turn to the last page. Take a look at the last page of this worksheet. This, by the way, is your next assignment that I'm going to have you do. But this is the last page that you're taking a look at here. It's kind of a summary and an example of what I'm looking for. Okay. First off, here's all the factoring thoughts that we've already talked about. Always check for greatest common factor, and then special case if you have 2 terms, 3 terms if it's in quadratic form, 4 terms if it's that grouping the box method. Okay, so this is just summarizing how to get your x-intercepts. Then if you take a look, the reason I wanted to go through this is just so you understand what I'm looking for when you start the process on this one. Okay, so if you notice, here's the example. I got an x to the 5th function, 5th degree function. So therefore, you should have a total of 5 roots on that one. Remember, that's one of your fundamental theorem of algebra idea is 5th power, therefore 5 total roots that'll match up. And the blank that goes here is basically asking how are you going to factor it. That's what I'm looking for. So in this one, there was an x that's the greatest common factor, okay, which then takes it to this x to the 4th. And now it's in quadratic form because there's 3 terms, and the middle term is half the original. And so even though it's not an x squared, it's still in that quadratic form where you start off with whatever degree, the middle term is half of that, and then the next term is down from there, okay, down to your constant. So that's what I'm talking about here when it says GCF and like quadratic factoring. It's similar. similar to that. The rest of it then, you can see the work, you go through and you factor it. You then could factor the x squared minus 4, okay? We could factor either of these, or at that point you can solve, okay? Meaning you could add the 4 over, take the square root, you get the plus or minus. Or I could have factored this to x plus 2 and x minus 2 and done it that way, okay? Same thing here. I could have factored this to x plus 1 and x minus 1, and then come up with my positive and negative 1 that way. So either way is fine. Ultimately, here's all your roots, and then you put it all together as your graph. And so I wanted to mainly give you that option so you can see what this was talking about and what I meant when it was this blank of what are you using. How are you going to go about factoring? This is what I'm looking for. Okay? So what I want you to do today then, with the rest of the time, we've got plenty of time to work. Number one, if you haven't done the graphing polynomials worksheet from the other day, that's the first thing you should do. That's due today. Okay? Number two is this worksheet that I just handed out. This will be due by Friday. Okay? And then number three, I've got that one Delta math assignment that's out there that's just kind of a review of everything. That's like 10 or 15 questions total. Okay? And it shouldn't take you too long to go through that. So those are your 3 assignments from this week. And then we'll revisit on Monday. The main thing I'm going to start with on Monday is this packet that I just handed out to you. Okay? We'll bring this up. We'll see if there's any questions on this. We'll talk about it. We'll go through anything and we'll go from there. Okay? You may also want to have your formula sheet out, so that way if you do have any difference of cubes, sum of cubes, things along those lines, you have those to work with. All right. Otherwise, I'm going to let you work, and I'll check in with you individually and kind of see where you're at and if you have any individual questions. Yeah.